Hello Physics Nation, my name is Nate Larmond and I'd like to derive a simple pressure at depth equation. Pressure equals rho GH, so what we're going to do is use four simple mathematical models. F equals ma, that is weight equals mass times the acceleration due to gravity. The definition of pressure, force divided by area. The definition of density, rho equals mass divided by volume. And how to find the volume of a prism. You just take the cross-sectional area and multiply by the height. So let's start with equations 3 and 4. We're going to substitute into the definition of density, mass divided by volume, what volume is equal to, cross-sectional area times height. So when you do that, you just get area times height in the denominator of the definition of density, and we're going to solve this new equation for mass. So basically, this is just density times volume. Now we're going to squish equations 1 and 2 together. So this is the weight of the water column above it. It's just the mass of the water column multiplied by acceleration due to gravity, and the definition of pressure. So you substitute in the weight for force, mass multiplied by the acceleration due to gravity, and then we're dividing by the cross-sectional area. But this mass right here is the same as this mass over here. So we're going to do a little substitution. Where mass shows up in the definition of pressure, we're going to substitute in rho area times the column height. When you do that, you see how we have an area on top and an area on the bottom, and they cancel, and we're left with pressure equals rho GH. So there you go. Thanks for watching. See you in the next video.